Okay, so question 28, exercise 28.2, question 4. Explain in each case why A dash is not the image of A under axial symmetry. So we start with the first one. Well, you can see that it's the wrong way around for a start. Okay, because it's not a mirror image. Okay, so that's the first thing. And you can see that this point here, this red point here and here, one of them's a distance of 3 away from the mirror, while the other one's a distance of 2 away from the mirror. That's wrong straight away as well. Now this one is a mirror image, but it's done slightly wrong. You see that this red point here is a distance of 1 from the mirror, while this the other red point is a distance 2 away from the mirror. This means that this is not a perfect mirror image. Okay, next one here, we can see that this blue one, now we see that they're both 2, that's okay. And the green dots are both a distance of 1 away from each other. So far so good. I bet this will be the mirror image. However, the distance between this green dot and this purple dot is a distance of 5, while on the original it's a distance of 4. This means it is not a reflection in axial symmetry under the line L. Just not going to happen, okay? Now, next thing around is the next exercise, which is question 24. PQRS is mapped onto P dash, Q dash, R dash, S dash under axial symmetry in the line X minus 1. Copy and graph and label the image. Okay, so here's what we're going to do. See R? We're going to do it at 45 degrees. So this blue dot here, R is going to go through like this. See, R is going to go from here to here. So that's blue dot to blue dot. Okay. Next thing we're going to do is S. Once again, we're going to go 45 degrees, which is 1 across, 1 down, 1 across, 1 down. And you can see that's roughly 1.5 diagonals. So I would put S around here. 1.5 away and 1.5 too. You can also use your ruler to measure this if you want. And you can see that it's the same length on both sides. That's the red one there, okay? Next one we have is P, which is going to be the green line. Okay, and once again we go diagonal. There's 1 diagonal, 2 diagonals, 3 full diagonals. So then another 3 full diagonals out the other side. So that'll be my green dot here. And then finally my purple dot, I suppose I call it. How many diagonals is this away? Well, this is 1.5 diagonals away, so we do another 1.5 diagonals there, and we'll get my other purple dot over here. Next, I'm going to join these lines together, see what image it produces, and we'll use a different color if we can help it. I'll use a yellow line just to show you what my image looks like. So here we are here. And now, if you want me to take away all these dotted lines, there you go. There is a mirror image of it through the line, through that line, y equals x minus 1. What are the coordinates of the following ones? Well, this is R dash, this is S dash, this is P dash, and this is Q dash. So P dash is 5 minus 2. That's P dash. Q dash is 2 minus 2. Okay. R dash is 2, 0. And then S dash is 5, 1. Okay, well done. Now, next one. PQR is mapped onto P dash, Q dash, R dash under central symmetry in the point AA. So this is central symmetry question. Actually, I have to do question 7 first. My bad. Let's do question 7 for Liam. It's an extra question in this whole thing, okay? Now, ABCD is a rectangle. So AD is the same length as BC. DC is the same length as AB. But then it also says that also says that ABDX, which one's ABDX? ABDX, no, where is X? Oh yeah, there's two parallelograms. Okay, so we have two parallelograms, okay? So name 3 line segments equal to DC. Okay, 3 line segments equal to DC. Well, as it turns out, the two parallelograms are also equal to each other. So I'd say that these two here are also equal. So I think it's going to be X to D. Now, why are the two parallelograms equal to each other? You probably might be asking, okay? Well, you can see that these are the two parallelograms we're talking about, and they both have the same. See, AB is equal to DC, DC is equal to BY, and AB is equal to XD. So we can see that all of them are equal to each other, okay? Because they're opposite sides of a parallelogram. So anything with a double dash through them are equal to each other. And then I'll obviously triple dash this side because they're equal to each other as well. Now, so we have XD, you could have AB, or you can have BY are equal to that, okay? What is the image of BCY under central symmetry in C? Now let's see where BCY is. B, C, and Y. And they all have to go through central symmetry in Z. B turns to D. Y will turn into X because you see Y to Z and then Z to X. It's all along the one line. Okay, so what's it? Y turns into X, and then finally we have Y turns into X, and then C will turn into A. See the way C to Z and then Z to A, so it's DAX. Okay, so that was a relatively easy one. Okay, let's go again. What is the image of AXD under axial symmetry in the line AD? Now, where is AD is what we need to figure out. AD is here, so this is our mirror. Okay, so A is on the mirror, so A stays the same. X is not on the mirror, so you go X to the mirror, then out the same amount out the other side, and it turns into B. So AX will turn into, sorry. Did the wrong question there. It's a triangle AXD. So A stays where it is, D stays where it is because it's actually on the mirror, and the only difference is that X will turn into B, ABD. Okay, so that's that one done. ABD. Now, what is the image of AX under the translation BY? AX, which is this line here, under the translation B to Y. B to Y means we have to skip across this distance here. This means A will turn into B and X will turn into D. So it's going to be B, D. B, D. Okay. If the angle AXD is 40 degrees, so A to XD, that's 40 degrees here. What is the angle ADZ? A to D to Z. Well, look, that's 40 degrees as well because it's part of the same parallelogram, which would mean ADZ is 50 degrees. The area of AZD is 8 centimeters. Great, 8 centimeters worth there. What is the area to figure AXCY? AXCY is the full thing. Okay, well, this is going to be fun. Well, I think we have it. 8 centimeters here. See this one here? It's the same size as this one here, which is another 8. And then that's half a rectangle, which makes that another 8. And then this is a parallelogram similar size. That's also an 8. So the whole thing is going to be 32 centimeters squared. Okay, now we're on to question 8. PQR is mapped onto P dash q dash and r dash under central symmetry in the point 2, 2. Copy and draw it out first, all right? So central symmetry. So P to A is 3 up, go another 3 up, and we find out what P dash is. To go from R to A, you go 1 down, 3 across. So you go 1 down, 3 across, and then you go another 1 down, another 3 across, and that'll be R dash. And Q dash is going to be 4 to the left, 1 up. Therefore, it's going to have to be another 4 to the left and 1 up. And there's your Q dash. Now, when you draw this new one, like so, there you go. Now, if you aren't sure about whether it's right or wrong, if you always link up to similar sides, if you go P dash to P dash, Q to Q dash, and R to R dash, they all have the same central symmetry. Okay, so that's how you know you're right or wrong. Okay, so it's going to be P. P is 2, 5. P dash is 2, 5. Q dash is minus 2, 3. And finally, R dash is minus 1, 1. Right, done and dusted. Next question after that. Okay, question 26 on one of the other exercises. I'll get it in the title of the video, so I don't need to worry too much. Okay, copy the graph in your copybook. Find the image of triangle A under axial symmetry in the line x equals 1. Well, x equals 1 is this red line here. So we go 1, 2, so I'm just going to color code the triangle, green one and a red one. Now the black dot will have to go 1, 2, 3, 4, 5 to intercept the red line, which makes it another 5 out the other side. There's our black dot. Our green dot likewise is 5 across, so 1, 2, 3, 4, 5 across, another 5 across. There's the green dot. And finally the red dot will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And therefore we have our image triangle B here. That's triangle B. I actually prefer my black line, to be honest. There it is there, triangle B. Now, the next one is in the line y equals 2. That's the horizontal line. So once again, see the green line here? It's 2 away from that y equals 2 line. So we'll go 2 down and then another 2 down to get the green one. The black one is 1, 2, 3, 4, 5, 6 down, which means if you go another 6 down, you'll end up here. And then if you go 2 down here, you can go another 2 down underneath, and therefore you have yourself a nice triangle mirror image. And that is the triangle C. Describe a single transformation that maps A onto the triangle C. Have an idea. Let's see if we can get some central symmetry going on here. Okay, U to U, black to black, and red to red. Ah, there we go. What's it? It's central symmetry in the point 1, 2. Okay. Question 35. Diagram shows 6 square tiles which are arranged to produce a repeating pattern. As shown, describe fully the single transformation which maps the tile phi q r, phi w r q onto the tile x w r s. Okay, best I shade this in because I am confused. Phi w r q, where is phi w r q? Okay, so this one here. And they want me to turn this one into XWRS. XWRS, which is this one here. I suppose 2 ways of doing. Oh wait, the patterns have to be the same. Oh, we get it now. Yeah, it's a mirror image, guys. Look straight down the middle here. See the mirror image left and right. It's symmetrical on both sides, so it's axial symmetry. So part 1 is going to be axial symmetry in WR. WR. Is that okay? Or it could be axial symmetry in BR. Okay, whichever one. I think WR is going to be the better answer there. Okay, good job. Now, the tile ABWV. So where is ABWV? ABWV is this one here. And we want to turn that into SRWX. So SRWX is this one. And ABWV is this one here. Now, let's find out. Okay, let's create some dots here. This green dot here is identical to this green dot here. This red dot, which is in between light blue and white, is equal to that red dot there. This black dot, which is at the top, what does it have? It has dark blue on top and then white. So that one will have to be this black dot here. And finally, this dot here stays where it is. So that is central symmetry in the point W all day long. Central symmetry in W. In W. Okay. Next one, the tile UVQP. Where is UVQP? There's U, V, Q, and P. We'll do P in yellow. Okay. And it moves on to YXTST. Okay, you can see there's a bit of a, if you look at the two of them, they're mirror images of each other, okay? But where is the mirror? So if I was to bring that across, like so, you can see that they're actually mirror images of each other. See that? So it's got to be axial symmetry. But where's the axial symmetry going to occur? Well, let's go V to V. V is the same as X. Q is the same as S. U, which has the two white triangles, is the same as Y, which also has the two white triangles underneath it. P, which has a white one to the left and a light blue one to the right. You can see it's the opposite way around because it's mirror image. So where's the center of all this? There it is. Central symmetry, axial symmetry in W, or it's actually the same answer as part 1. So that is also the answer for part 3. Okay, and finally part 4. The tile ACXV onto the tile QSXV. Okay, say that 3 times fast. Now let me see. ACXV. ACXV is the big red rectangle here, and it maps onto QSXV. Now you can see there are mirror images. If you look at different points here, if you take this point B, B is the same as R. A, which has the dark blue and light blue, is the same as Q, except the opposite way around. So they're definitely mirror images of each other. C is the same as S. So we're talking mirror images. So we're talking axial symmetry in VX. Okay, guys. I think that's me now. I think that's the last question. Yep. All good. So let's see where I put my list of questions here. All right. This is going to be a long video.